Ever wondered how safe you are inside a building during an earthquake? It's an unsettling question, isn't it? The ground beneath us, typically a symbol of stability, suddenly becoming unpredictable and dangerous. In these moments, the strength and design of the buildings we inhabit become our lifelines. Architecture then plays a pivotal role not just in shaping our cities but in safeguarding our lives against nature's unpredictability. Well, architects have been pondering this question for centuries. In ancient times, architects focused on flexibility to withstand the earth's shakes. They knew that rigid structures would crumble under nature's wrath, so they ingeniously opted for flexible materials and designs. Let's travel to ancient Japan. Here, the innovation was in the use of wood, a material that bends without breaking. The Japanese also designed buildings with a broad base and a narrow top, a style known as the pagoda design. This allowed structures to sway with the earth's movements, not against them. Now let's time travel to the ancient Incan civilization. Marvel at how the Incas skillfully fitted stones together with such precision that even a razor blade couldn't penetrate the gaps. This interlocking method made the structures flexible, allowing them to absorb seismic shocks. These early civilizations, with their ingenuity and understanding of nature's power, laid the groundwork for what we see today. These ancient methods were the stepping stones to modern earthquake-proof architecture. As we entered the modern era, our understanding of earthquakes improved. We began to unravel the mystery of these destructive forces of nature and, in doing so, developed a range of techniques to protect our built environment from their wrath. The birth of modern earthquake-proof techniques marked a significant turning point in our architectural history. A crucial aspect of these techniques revolves around the selection of building materials. Steel and reinforced concrete, for example, are favored for their flexibility and strength. They can bend without breaking, making them ideal for withstanding the pressures exerted by an earthquake. However, it's not just about the materials we use, but also how we use them. The shape of a building plays a significant role in its ability to resist seismic forces. Rectangular and circular designs are generally more resilient, as they can distribute stress more evenly across their structure. Meanwhile, irregular shapes with abrupt changes in height or width can create points of weakness, leading to potential collapse during an earthquake. Then, there's the foundation. The bedrock upon which our structures stand can significantly influence their survival. Deep foundations that reach stable ground and raft foundations that distribute the weight evenly across a wider area are common strategies employed to improve stability. But perhaps the most significant development in this era is the introduction of seismic codes and standards. These guidelines, born out of painstaking research and tragic lessons learned, dictate the minimum requirements for designing and constructing earthquake-resistant buildings. They cover everything from site selection and building design to construction materials and practices. These seismic codes are continually evolving, reflecting our growing understanding of earthquakes and our technological advancements. They serve as a testament to our commitment to creating safer living spaces and our resolve to stand up to nature's fury. These modern techniques have saved countless lives, but architects are always looking for ways to improve. Our quest for safer structures is far from over. The journey continues, fueled by our innate curiosity and unyielding spirit of innovation. In the 21st century, we have seen some truly groundbreaking innovations. The field of architecture is no exception, particularly when it comes to earthquake-proof design. The latest advancements are transforming the way we think about constructing buildings in seismic zones, making structures safer than ever before. Let's start with base isolation systems. This technology is like giving buildings a set of shock absorbers. These systems are installed between a building's foundation and its structure, allowing the building to remain relatively motionless while the ground beneath it shakes and rolls. It's a bit like watching a tall tree sway in the wind. The trunk remains still while the branches move. This simple yet ingenious solution has been a game changer in earthquake-prone areas. Next, let's talk about energy dissipation devices. These devices, often referred to as dampers, act like a car's brakes. They absorb the seismic energy that would otherwise cause a building to oscillate, reducing the impact of the quake. These devices come in various forms, like viscous dampers filled with thick fluid, or metallic dampers that deform to absorb energy. They're like the unsung heroes of the architectural world, quietly doing their job to keep us safe. And then we have shape memory alloys. This is where architecture meets high-tech materials science. These alloys can deform during an earthquake but then return to their original shape once the shaking stops. Imagine a building that can bend and flex with an earthquake, then simply bounce back once the shaking is over. It's a futuristic concept, but it's not science fiction. These materials are being used right now in buildings around the world. It's clear that the future of earthquake-proof architecture is here, and it's nothing short of extraordinary. These cutting-edge technologies are reshaping the landscape of seismic design, creating buildings that are not only more resilient but also more flexible and adaptable. These innovations are revolutionizing the way we design and construct buildings. So, what does the future hold for earthquake-proof architecture? A question that sparks not only curiosity but also a sense of hope. As we look forward, a key player in the future of earthquake-proof architecture is artificial intelligence. AI, along with machine learning, is set to revolutionize the field. These technologies will not only assist in predicting earthquakes with more accuracy, but also play a vital part in designing safer buildings. Imagine structures that can adapt and respond to seismic activity in real time, thanks to AI algorithms. Or consider the role of machine learning in analyzing vast amounts of data from previous earthquakes, helping us understand how to make our buildings even more resilient. Of course, none of this will be possible without ongoing research and development. The architects, engineers, and scientists of today are continuously pushing the boundaries of what's possible in earthquake-proof design. They're experimenting with new materials, developing cutting-edge construction techniques, and harnessing the power of technology to create buildings that not only withstand earthquakes, but also minimize their impact. And let's not forget the role of legislation and building codes in ensuring these innovations become the standard, not the exception. They guide the implementation of these advancements, ensuring that as we advance technologically, we do so responsibly and sustainably. As architects continue to innovate, the future of earthquake-proof architecture looks promising indeed. Have you experienced earthquake-resistant buildings? Share your thoughts and experiences in the comments below.